All right, good afternoon. Today's lesson is on function notation. Sorry about the recording earlier. It didn't work, but that's all right. So the vocabulary that goes with the Algebra 1 lesson is function notation. That is the notation where we write it as f of x. It's another name for y. So what I wanted to show you is with the newer calculators, when you turn on a graph, what you'll see is f of 1 equals x, and that's the same thing as y equals. So let's talk about what we're doing. F of x is the same thing as y. So when we are matching a graph or matching a function with a graph, what happens is our first example is a linear function. So we have f of x is equal to 2x minus 3. And I know some people said earlier it was hard to see the graph. So let's put it on a calculator and see if that's easier to see. So we have 2x, minus 3. And we hit enter, and that's going to be our graph. There we go. So we can see a better picture of the graph. And if you would like to see a better image of the table for where specifically those points are plotted, you can press the control button in blue and then the letter T. And that will get you the table right beside there. So the main point is the y-intercept is 0, -3. And then you can plot any of the negative points or any of the positive points. And all I'm doing is using this button here to either go up or down. All right. So the other function that we have on the right-hand side is a quadratic function. Some of those words may sound new, some of them may sound familiar, but either way, here's what we're going to do. So we get ourselves another graph so that it's easier to see. And we'll put in x squared minus 1. So x squared minus 1. And so when you put it in a calculator, it'll look, oh goodness, that's very blurry. Let's see one more time. It'll look like that. So we'll press enter and you'll see a parabola, the name of a quadratic, and our equation is right there to the side, just in case if you was wondering, x squared minus 1. If you want to look at the table, once again, you can press the control button in blue and then press T. And that'll get you all of the data points that you need. So when x is a -1, y is 0. If x is a -2, y is 3. And you can also look on the positive side. Okay, that's my sketch of the two graphs for the linear function, 2x minus 3, and a quadratic function, x squared minus 1. So you can plot the points like you have here and connect your line that is continuous, and then the quadratic here. Okay, so next we're going to evaluate a function. When we evaluate a function, all we're going to do is substitute the value of x into the equation. So our first example is f of x is equal to a -4x plus 7 when x is equal to 2 and when x is equal to a -2. So we're going to start off when x is equal to 2. So everywhere there's an x in our original equation, we're going to replace that with a 2. So I'll rewrite it as f of 2 equals a -4 times 2 plus 7. Okay, so all I'm going to do now is simplify what I can. A -4 times a +2 is going to be a -8 plus 7. So what you'll find is f of 2 equals a -1. Take a second, pause the video if you need to write that down. The next one that I want to do is going to be when x is equal to a -2. So just like on the original where I replaced every x with a 2, now I'm going to replace every x with a -2. So I'll start off with my same f of x, but in this case x is a -2. equals a negative 4 times a negative 2 plus 7. And then simplify as much as you can. If you want to work ahead, just hit pause, and then in the end, we'll talk about the answer. So if you simplify and you have f of a negative 2 equals a negative 4 times a negative 2 would be a positive 8 plus 7. So f of a negative 2 is going to equal a positive 15. So your final answer here is f of 2 is a negative 1, but f of a negative 2 is 15. I'm about to say 16. Okay, so I put the calculator there just to show you some of the steps that you can go through to figure out what those values were. So one way to do it would be to use the calculator feature, or you could use the scratch pad one. It doesn't matter. I prefer you to use this one because each time you get ready to do something different, you'll have a fresh start. So our original function was negative 4 times x plus 7. Now, if you want to substitute in a 2, what it'll look like is a negative 4, and just like we open parentheses on the paper, we will open parentheses on the calculator, plus 7, and then hit enter, and that's our answer. So f of 2 was a negative 1. I plugged it in just as I saw it, and I got a negative 1. Now, another way to do it, okay, just a little tidbit. If you don't feel like typing the whole thing over, you can arrow up twice and hit the enter button, and then just change the 2 because the second one said that x was a negative 2. So since x is a negative 2, I'm going to put a negative sign in front of the 2 and then hit enter, and we got our same 15. So f of a negative 2 is going to be 15. And that's our original answers that we came up with. Okay. Just like the last one, this is option 2 if you want to use the graph, and I have the graph feature highlighted there. And you want to type in just what we had, our original, negative 4x plus 7. Okay. Doesn't matter that the graph is linear and it made a line. You press Control T to get yourself to the table, and we needed to know when x was 2 and when x was a negative 2. So here we go. X is 2. Y is a negative 1, and when x is a negative 2, y is 15. That will be your second option to using the calculator to figure out what a function equal at a certain point. Okay, so on this last one, we have using function notation to solve n graph. So we have given f of x is equal to 6x plus 9. We need to find x when the equation equals 21, or f of x is equal to 21. So what's going to happen is that I'm going to take this equation, and instead of writing f of x, I'm going to replace that with 21. So here's what it's going to look like. So in replacing f of x with 21, I'm going to say 21 equals 6x plus 9. And this is why we solve two-step equations. So all I did first was just substitute it in. Okay, and now what I'm going to do is subtract. And what I'm going to subtract is 9 on both sides. So when I subtract both sides by 9, the plus 9 and the minus 9 becomes a 0, so it's gone. That leaves me with 6x equals 12. So then my last step is going to be to divide both sides by 6. So when I divide both sides by 6, I get x is equal to 2. So that lets me know that f of x is 21 when x is equal to 2. So my final answer could be when f of 2, when 2 is the value for x, the equation equals 21. So pause it. Pause it so that you can write that down. Okay, so I put the calculator there because I just want to show you another way to do it using a calculator. So we have given that f of x is 6x plus 9. So what I'm going to do on the calculator is just type in 6x plus 9. And I'm trying to hold it steady So we get a linear function. Okay, wonderful. But now we need to look at our table of values. So we have f of x when it equals 21. So what happens is, well, ta-da, it's really right there, but x is 2 when the equation equals 21. What I don't want you to do is arrow down to 21 and say, oh, my answer is 135. Well, we're not looking for y. What we're saying is that when y equals 21, whoops, went too many. What is the value for x? And x is going to be 2. Now, don't forget to get to the table. I press Control T. Now, that concludes our lesson. I put a little bit more on here because I wanted to make sure that we talked about the calculator features and how it may help you. Now, if you want to do it by hand, you go right ahead. Be my guest, but make sure that we understand the difference. When we evaluate a function, we substitute in our values and we're looking for what it equals. When we are working backwards sometimes, is we may have to, whoops, that's not the page. I rewrote it. But anyway, if we're working backwards and we know that the graph equals 21 or the function equals 21, we set the example or the expression that we started with to 21 and then work backwards to find out the value for x. Okay? But also, in function notation, don't forget, when you see it on a calculator, this is what you're going to see. So I want you to get used to this. Now, one other thing is that you may see, and I'm going to just write it off to the side. You may see f1 of x. You may see f2 of x. You may see f3 of x. It just really depends on where you are when you're graphing, because you may have a couple of extra things inside the calculator. I don't know if you can see, but you see it says f of 4. If I go up here to 1.7, let's see, that says f of 3. So this just tells you how many graphs you have in here. There's nothing there, nothing there, nothing there. But I'm pretty sure I'm going to get to f of 2. And if I go one more, so that's f of 2, then I have f of 1. Down there. So it just really depends on how many graphs you have, what number you'll see on the side whenever you press, whoops, the graph button, which is there in blue. Okay, so notice it says f of 5. Okay, if you have any questions, Ms. Gable is here for you. Make sure that you write down your notes and also complete the practice assignment. That is all I have for you. Don't forget, I want you to always try and do your best, and Ms. Gable loves you.